Hi, I'm just getting some readings here from my Newman motor. It's the meter's hooked up to this battery on the back end, and I'm trying to charge it, so I'm just measuring the readings here. This is a simple setup. I have 200 turns of 28 gauge thin enameled copper wire. I've burned off the ends to attach the leads. There's a somewhat dead 9-volt battery powering this thing, and a rechargeable AA hooked up to the back end. I'll see if it charges. This is the reading I'm getting from the back end. That's just a nail going through folded over cardboard, which I wrapped wire around. You can't get much cheaper than that setup, and taped it down because it tends to move a lot. If you can see, can you see the spark on the nail? Oh, and the commutator is masking tape wrapped around the end in a spiral to create the make or break connection for the all-important pulsing. And that is a reed switch on the end, which the theory is that it will be activated by the motion of the magnet. Close, open, close, open. I'm not sure if it's functioning that way because the magnets are so strong. It's possible that it's in the on position the whole time. But it is helping the commutator to stay in place rather than just a wire. I would have to have something there like a lead at least. So my next version of this, I think I'm going to build something a little bit more solid than the cardboard. But the idea here, if you build your own, is to get the copper wire as close to the magnets as possible. You lose a lot when you build these big fancy motors that are solid, but then the copper wire is too far away from the magnets. You really lose a lot. The magnetic field has to be right there, coupled together, so we get the full effect of the magnetic field growing, collapsing, sort of oscillation, I guess. Or could just be it needs to be close because it's taking the electrons from the copper wire and the magnets. I built this other one here, and you can see how the magnets, this is just a nail, but the magnets are a little bit farther away from the copper wire, and it's separated by this plastic from the jar. And this one doesn't work as well as this one, where I have the copper wire really, really close to the magnets, which you can't see because I have to tape it down. But anyway, the whole point of this is just to get these measurements from the back and see if I can't charge this battery back here. Let's see if I have a good connection here. Oh, touched it. Oh, no, I touched it. Still going. So now the pulses are slower because I accidentally touched the back of it. There. Not a really tight setup here, but this is just an experiment. The next motor will be more solid than this one. But very important keep the copper wire close to the magnets for full effect. And I think that it doesn't even matter how many magnets you have or how many turns you have. It's all about the connection, because that's where the energy is coming from, supposedly according to Newman. It's pulsing the electrons from the mass of the copper. And then I guess the copper perhaps regenerates itself once it loses its electrons. You know, probably gets its electrons back just from the air. And that's what we're going for. That's radiant energy. So if anybody's worked on this and has any comments, please let me know.